Hi, what's up, guys? Welcome to today's Leetcode Sunday contest. Today we'll be discussing problem number two, and yeah, let's get started. So, uh, yeah, so maximum items from sale one. So here, the problem states that like we are given some items, right? Which has two characteristics. It has a factor associated with it, and it has a cost or a price associated with it. Okay, which enables you to buy a item. Now, if you decide to buy some item, let's say there are n items, right? So 1, 2, 3, 4 till n. So if you decide to buy, let's say, the third item, buy this. Okay, so if you decide to buy this, then the question states that uh, if you buy at least one copy of it, then we receive one free copy of every item j, such that the factor divides the other factor. So what that means is, let's say we decide to buy item number 3, then and its factor was, let's say, 2, right? So all the items having factor 4, 6, 8 and so on become available to us for free. Okay, we can buy one copy of each of these. Okay, so and you can buy one copy of this, and these are free. These are free, and you get one copy of each of these as well. So if you're also free to buy two copies of these, or three, four and so on, like up till how much ever budget you have, you can buy those many copies, right? But even if you buy three copies, then you'll only still get one copy of the other, like the factors, for free. It's not like you buy three copies, then you get three, like you can buy the free copies three times. It's not like that. Okay, and that's what it's mentioned, I think. Buying multiple copies of the same item I does not give additional free copies. Okay. Cool. So that's the problem. And you're also given a budget B. So the problem is now pretty straightforward. It says that, given a budget B, tell me the maximum number of items that you can buy under these under these constraints, basically. Okay. So what I mean, the first thing that comes to my mind is, like, we need to know how many factors exist, right? So if an item has a factor of 2, then we need to know how many other items have a factor of 2, 4, 6, 8 and so on, right? If someone has factor of 3, how many other items have 3, 6, 9, 12 and so on, right? So this one you can easily compute using uh, I mean, the price factors go till 1500, right? So you can compute this in 1500 square of 1500 square, right? It's easy to do this. We'll see. You can do this using a hash map and some array tracking or something. Okay, cool. So the next thing that we'll do is we'll write the DP equation, and this obviously hints at a knapsack style DP, right? Because we are buying items, and we are also buying some copies of these items, and we are also having some cost associated with it, right? So our DP would look like this. We'll write a very generic DP, and then we'll optimize. So DP of ij is number of items, I mean maximum number of items, max number of items we can buy till I till item I, such that budget is j, such that our budget is equal to j. Okay, very simple. This is the knapsack DP that we see. So how do you, I mean, here the constraint is that we are able to buy multiple copies of the items, right? There are multiple copies that we can buy. um, Yeah. So if so in this case, if there are multiple copies, it becomes an unbounded knapsack problem. And when it is unbounded knapsack, you don't really track the first state, right? You only care about the second state. But here we do. I mean, here it will be easy for us to maintain two states, as we'll see, because um, because of the this particular constraint where the factors are also coming in the picture. So we'll see how that will help us. Um, so how do you write this? So let's say we decide to buy we decide to buy C copies C copies of item I. Okay. So then our DP would look like this. DP of ij would be DP of I minus 1, and j is your budget that you have. So if you buy C copies of item I, and let's say the price of item I is P, okay, so you would need C into P amount to do that action, right? So how much budget would you have left? So you are left with J minus CP budget, right? So you had J amount, and out of that you took C into P money out of it to buy C copies of item I. So now that's why you are left with J minus CP amount. Okay, and in return you got C copies. You got C copies of item I, plus you need to add how many free copies you'll get as well. So if let's say item I had a factor of f, so then you would have items like f, 2f, 3f, all of this stuff you'd get for free. Okay, and there's just one small nuance here that you cannot consider the same item like f, then f is divisible by f, but it also means that you're counting double counting the same item because C copies you already bought, so that it's already counted, right? So I mean it's just like one edge case handling, but yeah, just a point to keep in mind. Okay, so let's say this value is let's say free of f, right? So it just depicts how many items do you get for free if of it's if the factor is f, right, which we already computed here. So you just write that down, plus free of f. Okay, yeah, minus 1. Minus 1 is important because of the edge case that we saw. Like you already have, I mean, here I am assuming that C is positive, right? So you already bought item I, you already counted it in the C, right? So you don't want to double count it here. Yeah. Okay, cool. So now what we'll see is yeah, let me also rewrite this. Let me erase this arrow and have this dp of ij written here. Okay, C is positive, and if C was 0, then we'll see that case later, but it's very easy. So what's the complexity here? Here we are having C as a variable, we are having J as a variable, and we are having I as a variable. So obviously it is some cubic solution, right? So I goes till N, J goes till the budget B, and C goes till, I don't know, like J by P, I think, right? So it's like B by P. P is the price of some item. Like you can have if you're calculating the complexity, you always assume the worst case. So B by the minimum amount. So obviously this is O of NB square, right? Minimum amount can be 1 rupee. I mean one whatever the currency is. So this is O of NB square, and we don't want to get into this because this is just TLE. So how do we improve it? How do we improve this this knapsack state? I mean the recurrence that we wrote. So one important thing to notice here is, let's focus on this term J minus CP. So J minus CP is budget after buying C items of type I having cost P. Okay, I mean that's what we saw. So this is the budget after buying C items of type I having cost P. So let's write this down. Let's denote this by J prime. So J prime is, let's say, J minus CP. Okay. So what is J? J would be J prime plus CP, right? J is J prime plus CP. Now, so if you see, there's a very nice characteristic of representing our DP. Like, what essentially what we are trying to get at is, like, if you want to buy C items of a particular type, then that has to come from a previous C item kind of case. So for example, here, right, the if you think like this, like, let's say that the range of J prime is from 0 to P minus 1, right? Because if you cross P, I mean, if let's say J prime was P, let's just put that J prime was P, okay, that means that J would be P plus CP, which implies it is like P into C plus 1, right? So you're buying C plus 1 copies, but we only wanted C copies, right? So that's why our range of J prime is 0 to P minus 1. It's basically the modular range, right? And let's take one more example. If let's say J prime was, let's say, 3P plus 5, then that would imply that your J is like something like 3P plus 5 plus CP, right? So this is like C plus 3 into P plus 5. This I mean, this wouldn't lead you anywhere. This 5 factor is just lying there. It's like you're not buying anything with it. You already got C plus 3 items, and we didn't even want C plus 3 items. We wanted C items exactly. So yeah, anything beyond P or greater equal to P is useless to us, right? So remember that. Okay, so now that we are like have a intuition about what J prime can be, it's like, I mean, what's useful to us. Let's take a closer look at how we want to represent budget. Okay, so let's say J prime was 0. So that means that your J can be P, it can be 2P, 3P, so on. So basically I'm saying it's like 0 plus CP, right? And C can be 1, 2, 3, up till whatever the budget is, right? Let's say J prime was 1. So then it can be P plus 1, it can be 2P plus 1, it can be 3P plus 1, up till B, whatever the budget is again, right? And similarly, if you have P minus 1, it can be like P plus P minus 1. So 2P minus 1 can be 2P plus P minus 1, which is 3P minus 1, and so on up till the budget, right? This is like 1 plus CP, and this is P minus 1 plus CP range. Okay, I'm just substituting the residues, I mean the modulos here. So if you see, this will make the budget space. This entire thing makes a budget space. Is essentially O of B. And you can also prove it because there are no two same numbers in this modulo class. So how can I prove it? So if I say x1p plus r1 equals to x2p plus r2, right? So r1 and r2 are the reminders. I mean, r1 and r2, where r1 and r2 are less than equal to p minus 1, and greater than or equal to 0. Okay, so it's like x1p minus x2p equals to r2 minus r1, right? So r2 minus r1 is in the range minus p minus 1 to plus p minus 1. So that means that x1 minus x2 into p is less than or equal to p minus 1, and like this. Okay, so what this means is your x1 minus x2, like there's like 0 multiples of p in this range. Like this is a multiple of p, right? So if you put like 1 over here, then p is not less than p minus 1. So x1 minus x2 has to be 0. That means that x1 equals to x2, and that means that if x1 and x2 is the same, we just substitute it here. So x1p plus r1 equals to x1p plus r2. So that also means that r1 has to be equal to r2, right? So that means the number is unique. So there is no equivalence, like there are no two numbers in this budget space which can be equal to each other. They are all mutually exclusive, or they are all unique, and they constitute of all the b numbers entirely. I mean, yeah. um, so yeah, having seen this, now our problem becomes very easy to solve, because now what would happen is that you have your j prime belonging from 0 to p minus 1, right? And then you have your j which is initialized with j prime, and then it will keep incrementing by p, right? And we'll also track the number of copies, like c++, let's say the copy is c. Okay, so now we can rewrite our dp like this. So let's say if I have dp of I comma j, so let's say for example j was 4p. Okay, so I comma 4p. So how would you reach 4p? In order to reach 4p, you can have bought 2p books. I mean, sorry, 2p. I mean 2 items, right? So in order to reach 4p, you can have bought, let's say, 3 items, or you can have bought 2 items, or you can have bought 1 item, or you can have bought 0 item, right? So what I mean is, like, let's say it's dp of I minus 1 comma 2p. So this means that how much budget have left. So I am remaining with 4p minus 2p, which is 2p budget. So that means that this 2p, I can still buy 2 extra items. So I will just add a 2 here, plus 2 plus whatever the free value is, right? So free of f. This is very easy to handle. And what other states can I reach? So I can also have this state dp of I minus 1 comma p. So that means that I still have 3p budget left. So 3p budget I can spend on buying 3 books. Oh, sorry, 3 items, right? Plus free of f again. So you need to have some kind of prefix maxima here. That's what I'm getting at, basically. So if I write it in a generic way, so in any case, if dp of I comma like you have, let's say, I don't know, r plus tp, or I mean, how can I write it? R plus, let's say, cp. Yeah, let's write cp. R plus cp would be dp of I minus 1 from the same residue class R. So if I do this c1p, this would become c2p. Okay, plus where c2 is less than or equal to c1, and then you can still buy C1 minus C2 books, right? So what's the cost of this? The cost of this, how much money you spent? So you spent, you're left with R plus C2P, and then you also add, let's say, C1 minus C2 into P amount, right? So this would give you R plus C1P, which is this budget that we had. So we came, I think we came a long way from our equation here, where we just said that we had C copies exactly and we wanted to preserve these C copies. But along the way, what we saw was, in order to break out of this TLE, we needed to think a bit differently, because if it's Jplan plus CP, and in order to preserve C copies, we needed to look at the uh, residue classes, basically from all the numbers from 0 to P minus 1. And then you just had to enumerate these classes. Like if J prime was 0, then do P, 2P, 3P, right? And from there we saw that we cover all the budget values, all the values under the B space, right? And in order to like, let's say you're enumerating J prime equals to 1 here, and you are standing over here, right, somewhere over here, let's say at 7P plus 1. So in order to reach 7P plus 1 budget, you could come from here, you could come from here, you could come from here, but you could have never come from here, right? Because then you would be left with some extra money, which would not be helpful in buying the C copies that we needed, right? So for example, I'll just take a small example again. So let's say if you are calculating for 8P plus 7 and DP of I, and let's say you had DP of I minus 1, and let's say you had 7P plus 6, okay? So how much money are you left with? You're left with 8P plus 7 minus 7P minus 6, which is P plus 1. So in P plus 1 amount, you can only buy one book, right? So you can just add plus 1 here. This 1 rupee that, or one currency that you have, is extra. It's of no use here, right? So you cannot do anything with this, right? So it's always better for us to remain in the same budget space, and that too the prefix of it, right? In order to exactly buy the C copies that we wanted. Yeah, I think that's the idea. That's the idea of the problem. I know it's kind of a hard problem. I don't think it's a medium at all, because uh, coming from this to this, it does require a lot of, I think, scribbling around to get the idea correct, right? So okay, I will just I think I'll upload the code in the next video, because this video has got too long, right? And I hope you guys understood the explanation, but anyways, I'll be doing the code as well, so maybe you'll get a better idea of what I'm talking about. So here essentially the idea was like, for 4P you can come from 2P, 1P, 3P, or 0P, right? You could come from all of these places. And if you came from 3P, you can buy 1 copy extra, 2P will give you 2 copies extra, 1P will give you 3 copies extra. 0P means that you didn't have any budget and you spend it all on the copies, so it will give you 4 copies extra, right? And plus the freebies that you get. Plus the freebies, I mean this factor. So, and after that, you have to take the maximum out of all of these values, and that would be your answer for the state I, 4P. So if you see, this is the prefix max, and you can always maintain the prefix max very easily, like with the use of a single variable. So this has brought down our complexity to a 4 of n b precisely. Okay, thank you guys for watching. I'll soon be uploading a code, so yeah, please check it out as well. Thank you.